Okay, so we're, oops, I did not mean to do that. We are doing 3.7 and we're going to be doing 16 through 20. So they say the graphs of the polynomials from the previous problems are shown. Check your predictions. So you did some stuff over here. Let's see, you found the roots for them. So now you want to check if you got those polynomials. So let's see, here you were supposed to predict the number of roots. So we had just talked about like the fundamental theorem of algebra, which basically says, look at your highest power of x. So here it's 2. That's how many roots you should be looking for. So how many roots should be here? And someone says 3, Miss Johnson. And then how about here, this one? And you're like 6. Okay, good. So then you come over here. Now they want you to check, let's see, check your predictions and use the graph to help you write the polynomial in factored form. So in reality, we're going to say it should have 3 roots, and then you're going to write it in factored form. Those are the 2 things they want us to do. So here, this one should have 3 roots, which in this case, it has 3 real roots because look, I can kind of see them. And I'm going to kind of make this bigger so you can kind of see the graph. And you need to choose a root that would work for this. And it looks like these are all really good roots. So I'm going to actually write it. I'm not going to factor it at all. I'm going to write it from the roots. So for this one here, I'm going to pick off my roots. Where's my paper? Oh, here it is. I'm going to pick off these roots, and it looks like it's x is equal to -3, x is equal to -1, and x is equal to 3. So if I'm wrong, and this is like 3.1, when I check my answer, it'll come out. So once it's here with x is equal to -3, the step above this, if you remember, right, the step above this is when I write it using blah, blah, blah equals to 0. So then, I want each of these to say equals to 0, equals to 0, and equals to 0. This is a funny random fact, okay, about Miss Johnson. Like whenever I write equals to 0, this looks like a face to me, like it's on its side and here's the eyeballs and here's the mouth. Do you guys all see that? I know that this is a random fact that every single time I write equals to 0, I always see this. So I'm always like giggling in my head. Anyways, sorry, back to math. Okay, so how would I get this side equal to 0? What would I do to this -3? And you're like, oh. So I would, yeah, exactly. I'd add 3 to both sides. So this would say x plus 3. Similarly, this would say x plus 1. And similarly, this would say x minus 3, right? And then from here, I just write all of these guys in parentheses, and there's my factored form. X plus 3, x plus 1, x minus 3 equals to 0. So there's my factored form, right? And the way I check it, and I'm not going to check it right now, but if I had time to check it, which you should all do during your finals, hint, hint, nudge, nudge, wink, wink, right? Is I would go on Desmos and I would graph this thing, and then I would graph this thing, and I'm hoping that they overlap, right? So that's all you're doing for here. A really quick check for Miss Johnson in terms of making sure that this matches up is I multiply the first times the first times the first, and I get x cubed. And I multiply the last times the last times the last, and I still get -9. So I'm pretty sure that this is absolutely perfect. Okay. So number 17 is very similar, and you guys are like, Ms. Johnson, this isn't a polynomial, it's a line. Technically, this is a polynomial. Poly means many, nomial is like many terms. So it does have many terms, right? So Ms. Johnson, how would you write this in factored form? Just like before, we pull off our x-intercept, which in this case is, oh, you know what I forgot to do? The only other thing that I forgot to do was check to see if this has an A, but if you see right here, this doesn't have an A, so we're okay. Here, this does have an A, so we're going to play with that number, and you'll see how that shows up. And there's a couple different ways to do it, so don't say that this way that I show you is the only way to do it. So the very first thing that I'm going to do is I'm going to pull off this x-intercept. So here my x-intercept is -2. Okay, -2. So then what I'm going to do is I'm going to write the line above that, which would be x plus 2 equals to 0. And so my factor right now is x plus 2. Okay, the next thing that I would need to do is I'm pretending that they didn't give me this, okay? I'm pretending that this isn't available to me. So I don't know that the A is really -2, okay? So the next thing that I would do is I'd use another point, like say 0, -5 to find out what my A is. And so it would look kind of like this. A parentheses x plus 2 equals to y, right? And then I'd figure out like, oh, if I plug in 0, so here, let me go just to the direct left. If I plug in 0, 0,5, the intercept is 0, -5. And if I plug in 0, so I go A parentheses plus 2 parentheses equals 2, right? And if I plug in the point 0, -5, I should be able to find my actual A. I don't like this. 2A equals -5. A should be -2. Why isn't, oh, because I don't have my B. I don't like this way. Sorry. I'm going to nix this. So, the other way that you can find your A in this case, because it is a line, you can actually use the slope to find your line, right? So down to right 1, down to right 1, down to right 1. Does that make sense? Give me a second.